A third of every AI request American company sent this week didn't run on an American model. It ran on a Chinese one.
A third.
Above a third every single week since February. One startup moved 100% of its traffic off Claude onto a Chinese open model and saved millions of dollars in a couple of months.
Okay, but that's the cheap end pulling people down. That's not the news that surprised me today.
No, the news that surprised me is what happened at the top.
The top came down to meet it. Musk's lab drops a new frontier model and prices it at roughly a third of what the American flagships cost.
And calls it Opus Class, same tier as the best model money can buy.
Which is a claim, not a fact. I want to be careful there.
Sure, but hold both of those in your head for a second. Cheap models climbing up, the expensive frontier dropping down to meet them. On the exact same day, one of the big Western labs raised its price and started asking for your government ID before it'll let you in.
That last part is the one nobody's talking about enough. The best model is getting more expensive and more gated. Everything underneath it is getting cheaper and more open.
The floor and the ceiling are moving toward each other. And the question for everyone building anything is, which direction do you bet on? Alright, the headlines. And they're all pulling in one direction today.
The price of intelligence. Start with Grok.
Grok 4.5, new model out of Musk's lab. They've rebranded. It's SpaceX AI now, but it's the same shop. Ground up rebuild, not a tweak of the last one. Live in a few coding tools already. Full public release tomorrow.
And the pitch is the price. Roughly a third of what the American flagships charge, with a claim of comparable quality.
Which is where I stay skeptical. Somebody ran it head-to-head against the other frontier models on live coding tasks, and the honest read is, fast, cheap, genuinely good, and it fumbled one of the harder builds on the first try.
Competitive, not dominant. Every challenger says as good as the best, for a fraction. The public release tomorrow is when we actually find out.
But even competitive at that price changes the math. Which brings us to the bigger structural story, the Chinese open models.
This is the one that's been true for months and people are only now clocking it. American companies routing more than a third of their AI usage through Chinese open-weight models. DeepSeek, Zhipu's GLM, Qwen, Kimi.
Peaked near half. A year ago it was around a tenth. The reporting's from CNBC off usage data on one of the big developer platforms.
The mechanism's simple. These models are downloadable, they cost 60 to 90% less, and they score in the same neighborhood on real coding work. So teams default to the cheap one and only call the expensive Western model for the hardest problems.
A chief generalist on staff, a specialist consultant on retainer. And the caveat, that's where the cheap high-volume tokens go, not necessarily where the highest stakes work lands.
Right. Token share isn't revenue share, but the direction's not in doubt.
And on the very same day, Anthropic moves its top model, Fable 5, to pay-per-use pricing at the premium end, and switches on government ID verification to use it.
An order of magnitude above Grok, maybe more above the Chinese models. And you now have to prove who you are to get access.
The best model becomes a gated, identity-bound thing. Everything good enough becomes a commodity. That's the whole day in one sentence.
There's a governance thread there we could spend an hour on. Export controls treating frontier models like advanced chips. Some other time.
Then there's the one I did not expect a leaderboard leader to say out loud. OpenAI published a post basically admitting one of the most cited coding benchmarks is saturated.
Meaning the top scores stop measuring skill and start measuring noise. Leakage, brittle patterns, luck. They pulled their own recommendation to rank models by it.
Which is remarkable, because their models sit at the top of that leaderboard. It's a lab explaining why its rivals' high scores don't count.
And that's the honest catch. The critique is probably right. Benchmark saturation is real, but it's not disinterested. Both things are true.
It lands the same week everyone's citing coding scores to sell a new model. Awkward timing. Good timing, depending who you are.
Google shipped something too. Gemma 4.
Open weight, small enough to run on a laptop or a single GPU, and it handles text, images, and audio natively. There's a variant that skips the usual image encoder entirely. Feeds raw pixels straight into the main model.
Which is elegant if it holds up. The community's first note was that the report is thin on the ablations, so it's hard to tell which idea actually drove the gains. But the models are real and downloadable today.
And then robots, two big ones. Mistral, a language lab, shipped its first robot model. Steers a robot through a building it's never seen from one ordinary camera and a plain sentence.
No LiDAR, no depth sensors, beats the multi-sensor rigs. We're going deep on that one.
And a cluster of research papers, the top 3 on Hugging Face today, all converging on the same idea. Generate the world, not the movie. That's our main story. It's the best thing on the board.
There's also a quiet technical one worth flagging. A new attention method from Tencent that learns what to ignore in a long document. We'll get to it. It's tied to this whole cost story.
Couple of fast ones to close. A Brown professor suspected his students were using AI on a take-home final, moved it in person, and the near-perfect scores fell by about half.
Which is, roughly, a measurement of how much the AI was doing. Reported, not a controlled study. In-person exams are more stressful, that lowers scores on its own. But the direction's hard to argue with.
Microsoft open-sourced a little tool called Flint, gives an AI agent a reliable way to make a chart instead of handwriting plotting code that comes out broken.
Part of the week's real theme on GitHub, honestly. Agent scaffolding, tools that make these models dependable instead of just capable.
And speaking of which, a repo collecting the hidden system prompts of basically every major AI product shot up the charts. Claude GPT, Gemini, Grok, Cursor. The standing instructions each one runs on, side by side.
Extracted, not official, so treat them as a useful reconstruction, not gospel. But builders love them, because it's the difference between guessing at how to steer a model and reading how the best funded teams actually do it.
That's the board. Now the world models. So who are we? I'm Eris. I read the papers, I chased the threads between them, I'm the one going, wait, this connects to that.
And I'm Vestra. I take the thing Eris is excited about and ask how it actually works, and whether the number holds up when you poke it. Between us, we try to crack open a piece of AI research and hand you what's actually inside without the jargon.
And if you want the full daily rundown, every story we just went through and the ones we didn't have time for, that all lives on our news site, Ground Truth. Groundtruth.day, one clean feed every day.
Today's main topic is the one I think will still matter in a year. World models, and specifically a shift in what they're for.
For a while, AI generates video meant, make a pretty clip, a movie you watch. Today's papers are doing something different. They're generating a world you can act inside. Depth, motion, physical structure, the stuff a robot actually needs to reach out and grab something.
3 of the most discussed papers in the field today all point the same way. In a major lab, Mistral shipped a real robot brain built on the same bet. That the hard part of robotics isn't the sensors, it's the data. And you can dream the data.
Robots trained in a dream. That's where we're going.
With a stop at the end for a smaller, sharper idea. A way to teach a model what to ignore, which turns out to be the same story told through cost.
If that's your kind of thing, follow or subscribe wherever you're listening. It's the one thing that keeps this show landing in your feed every day. Okay, start with the problem because it's a good one. You've got these incredible AI video generators. They can make a photorealistic clip of a hand pouring water. Looks perfect.
And it's useless to a robot.
Why?
Because a video is flat. It's a picture that changes. It tells you what a scene looks like. It doesn't tell you how far away the glass is, what shape it is, which way the water's actually moving in space. And a robot arm needs exactly those things. It needs geometry, not a pretty picture.
This is the whole insight of the lead paper today. It's called RinWorld 4D, out of Alibaba's research lab. And the move is, stop generating just the color video. Generate the geometry alongside it.
Right, let me unpack the 4D, because it sounds like marketing and it isn't. 3 of the dimensions are space, and they get at space by generating a depth map. For every pixel, how far away is it? So the flat picture gets a 3rd dimension pushed into it.
Distance for every point in the frame.
And the 4th is time, but not just the next frame. They also generate what's called optical flow, which is, for every pixel, which direction is it moving and how fast.
So put those together and you don't have a video anymore. You have a moving 3-dimensional scene. You know where every surface is, and you know how every surface is about to move.
And here's the part I liked. Once you have depth and motion for every point, you can back it out into actual 3-dimensional movement, not the pixels shifted left. A real statement like, that object is traveling toward the gripper at this speed, in space. That's the thing a robot can act on.
And they don't generate those as 3 separate models that might disagree with each other.
No, that's the clever bit of engineering. It's one model with 3 branches. One for color, one for depth, one for motion. and they're wired together so they constantly check each other. The color says there's an edge here, the depth better agree there's a surface here, the motion better agree it's moving consistently. They call it cross-modal attention. The effect is the three views stay physically honest with each other instead of drifting apart.
And they had to build a giant dataset to train it, because nobody has video that comes pre-labeled with perfect depth and motion. So they took 250 million frames of people and robots manipulating things, and machine labeled all of it with the depth and the flow.
Which is a real caveat, actually. Those labels are estimated by other models, not measured by a sensor. So there's a quality ceiling baked in, but at that scale it apparently works.
Now here's where it stops being a video model and starts being a robot. Normally, to turn a generated video into an action, you generate the whole clip, which is slow. These things denoise step by step and then reason about it. They skip that.
This is my favorite mechanism in the paper. They don't wait for the finished video. They reach inside the model, grab its internal understanding of the 4D scene mid-thought, and feed that straight to the part that decides what the robot should do. One pass. No waiting for the pretty picture to render.
Because the picture was never the point. The point was the geometry, and the geometry's already in there.
And that's what makes it fast enough to actually control a robot in a loop. It's not real-time in the sense a video game is. It refreshes its plan about 9 times a second, but it plans a chunk of moves ahead, and executes them while it thinks about the next chunk. So the robot stays smooth.
And the payoff shows up exactly where you'd predict. The tasks that need real spatial sense. There's one where the robot has to pick something up with one hand and pass it to its other hand.
The handover, which sounds trivial and is brutal, because now the robot has to reason about 2 of its own hands in 3-dimensional space, near each other, one blocking the other's view. The big general-purpose robot models, the ones everyone benchmarks, basically can't do it. They fail almost every time.
And this one gets it right a meaningful chunk of the time. Not reliably. Let me be honest, it's still far from something you'd trust in your kitchen. But it goes from essentially never to often, and the reason is it actually knows where its 2 hands are in space.
That's the honest frame. It wins on the tasks where geometry is the whole game, and it's still research grade. The point isn't the score. The point is why it wins.
And now zoom out, because this exact bet just showed up in a product, Mistral, a frontier language lab, not a robotics shop, shipped its first robot model this week, navigation. You give it one ordinary camera and a sentence. Leave the lobby, go down the corridor, and it drives the robot there.
In a building it has never seen, and it beats the setups bristling with laser scanners and depth cameras. One cheap camera gets there roughly 3 times out of 4.
Which, caveat, means 1 in 4 it doesn't, and a navigation failure is a robot stuck or lost or into a wall, not deployable, but as a research result, inverting more sensors is safer. That's a real jolt.
And here's the thread that ties Mistral to the world model papers. How did Mistral train a robot that's never been in your building? It never touched a real robot. It practiced hundreds of thousands of runs inside a simulator.
A dream. It learned to walk through buildings that don't exist.
That's the whole bet, said out loud. The expensive part of robotics was never the sensors. It's the data. Millions of examples of a body moving through the world. And if you can generate that data cheaply, in a simulation or a world model, you've unclogged the pipe. Mistral did it with a hand-built simulator. The Alibaba papers are trying to do it with a generated world.
Same bet, 2 doors into the same room. So if the bottleneck is data, the obvious next question is, where does the data come from? And the companion paper to the one we just talked about has the most honestly science fiction answer of the day.
Set it up properly, because the current way is the villain here. How do you teach a robot to do a delicate task today? A human sits there and physically puppeteers the robot. Moves its arms through the motion over and over to record demonstrations.
Slow, expensive, and every single demonstration is chained to one specific robot in one specific room with one specific set of objects.
You want 1 million examples and you're collecting them 1 human hour at a time on hardware that costs a fortune. That's the wall.
So this paper, it's called RinWorld Teleop, says, take the real robot out of the loop entirely. You keep the human. The human just moves their own hands in the air.
And a world model watches the hand movements and generates the video that a robot would have produced if it had done that motion. From the robot's point of view,
there's no robot. There's a person waving their hands, and a model dreaming up the robot's eye view of the task getting done.
And this is the key. You get both halves of a training example for free. The video is what the robot would have seen, and the person's hand motion, the thing that drove it, is the action label. What the robot should have done. You need both to teach a robot, and here they come out together. No robot required.
And because the label is just hand poses, joint positions in space, it's not tied to any one robot body. You can take the same recorded motion and retarget it. Wheeled robot, legged robot, a different gripper.
Which is the thing physical puppeteering can never give you. There, the demo is welded to the machine you recorded it on. Here, the demonstration floats free of the hardware.
And they got it fast. Fast enough that the human stays in the loop. You move, the robot's eye world updates immediately, over 40 frames a second on a single high-end GPU. It's interactive. You feel like you're driving it.
Which matters more than it sounds. If there's a lag, the human can't chain moves together into a real skill. Real time is what makes it usable, not just a demo. And the way they got there is a trick worth naming. They trained a big, careful, slow model first, then distilled it into a lean, fast one that only ever looks forward, never back. That's what buys the frame rate.
And the headline result: they trained a robot policy purely on this dreamed-up data. No real demonstrations at all, and it transferred to an actual physical robot and worked.
Zero real robot time, and it crosses into the real world. That's the claim that makes the whole paradigm worth taking seriously. And when they mixed the dream data in with some real demonstrations, the success rates went up further. So it's not just a substitute, it's an amplifier.
Now there's a third paper in this cluster, and it comes at the same substrate from a totally different angle. It's called Alaya World, and instead of robots, it's worlds you can play.
This one's more of a full open source system than a single result, and they've been upfront that the complete details land mid-month. But the demo is a generated, explorable world. You walk around in it, and the model generates what you see next as you move.
And not just walking, you can do things. Cast a spell, fight, summon a creature, and the world responds in real time and stays coherent as you go.
The reason it belongs next to the robot papers, it's the same core problem wearing different clothes. Keep a generated world consistent over a long stretch. Let a user act freely inside it. Run it fast enough to feel live. A game engine and a robot simulator are, underneath, asking the model for the exact same thing.
A world that holds together while you act in it.
And I have to plant the flag on the caveat here, because it's the whole ballgame. These are dreamed worlds, and dreams get geometry wrong.
Say what that costs.
A world model can invent a surface that isn't there, or a distance that's slightly off. If a robot learns inside a simulation that's subtly wrong, it fails in ways that are subtly wrong. And subtle wrong is the hardest kind to catch, because everything looks fine right up until the gripper closes on nothing.
So the dream has to be honest, not just convincing.
That's the open question the whole field is sitting on. Not can we generate a world? Clearly, yes, today, multiple ways. It's can a machine safely trust a world it imagined? And nobody's proven that yet. These are same-day research papers, not products in a warehouse.
But the direction is unmistakable. 3 separate teams, one day, all deciding the future of robot data is generated, not collected. When the whole field leans at once, that's usually worth watching. One more, and it's smaller and sharper, and it's secretly the same story as everything else today. It's about cost.
This is my corner. It's a new attention method from Tencent. And to see why it matters, you need one fact about how these models read.
Go.
Attention is the mechanism that lets a model relate every word to every other word. That's its power. It's also its curse, because the work grows with the square of the length. Double the document, you quadruple the cost. 10 times the document, 100 times the work.
So long documents are where the bill explodes.
Exactly. A whole codebase, a whole book, a long agent conversation. That's the expensive regime. So for years, the standard fix has been, don't look at everything. Chop the past into chunks, and only actually read the handful of chunks that matter for the next word. Ignore the rest.
Which is obviously smart. The catch is, how do you know which chunks matter before you've read them?
That is the entire problem, and you just said it perfectly. The old methods pick the chunks with a crude rule of thumb. Roughly, squint at a cheap summary of each chunk, grab the ones that look relevant. And, when the rule of thumb guesses wrong, it throws away the chunk that had the answer. Quality drops. Which is why cheaper has always meant a little worse.
And this paper, Hiles, breaks that trade?
It attacks the guess. Here's the insight. Those old summaries of each chunk are basically an average of the chunk's contents. And the paper shows with real math that an average is only a good summary in one specific case. When everything in the chunk matters about equally. The moment one crucial sentence sticks out, the average smears it into the mush around it, and the chunk gets overlooked.
So the summary itself is the weak link.
So they make the summary learnable. Instead of averaging, they attach a little tag to each chunk. They call it a landmark, and that tag learns to be a good summary of what's in the chunk. And, crucially, the whole choosing process is wired into the model's training, so that when the model gets the next word wrong, the blame flows all the way back to the chunk selection.
Wait, so it's not just learning to predict text, it's learning what to pay attention to from its own mistakes.
That's the sentence. It learns what to ignore. Every time skipping the wrong chunk hurts its prediction, it adjusts what it reaches for next time. The selection gets trained, not hand-coded. Nobody had really pulled that off before without giving up the efficiency you were trying to save.
And the result?
Two things, and they're both a little wild. One, within the lengths it was trained on, it matches the expensive read-everything approach. It doesn't pay the usual quality tax. Two, and this is the eye-opener, you can feed it documents dozens of times longer than anything it ever saw in training, and it still finds the needle. Reaches way past its training range and mostly holds up.
Mostly.
Mostly is the caveat, and it's the same one all day. At the extreme lengths, it misses maybe one target in 10, which is fine if you're skimming, and unacceptable if that one fact was the whole reason you asked. And these are the author's own tests. On fairly clean retrieval puzzles, the real trial is somebody else running it on messy documents. Same as HiLS, same as the world models. Author reported until replicated.
But here's why I wanted it in today's episode. There's one more thing.
You can retrofit it. Take a model that already exists, do a light bit of extra training, and convert it to this cheaper attention, without rebuilding it from scratch. Most efficiency tricks force a from-scratch rebuild. This one doesn't.
And that's the connection to the whole day. Every headline this morning was the cost of intelligence falling, Grok's price, the Chinese open models. This is the same collapse, one level down, in the plumbing. Reading a long document just got cheaper without getting dumber.
The price is coming down from the models and from the mechanics at the same time. When the floor keeps dropping like that, the interesting question stops being, who has the best model?
And becomes, what do you build now that this is basically free? Which, honestly, might be the real story of the whole week. So if you back all the way out from today, one shape.
The cost of intelligence falling from every direction at once. Grok pricing the frontier at a third. Chinese open models taking a third of American usage from below. A cheaper way to read a long document underneath even that. And the one thing moving the other way?
The very best model getting more expensive and asking for your ID at the door.
The floor keeps dropping, the ceiling pulls up and away, and the gap between them is where every real decision now lives.
And the robots. Because that's the second half of intelligence is getting cheap. 3 teams, one day, all betting that the way you teach a machine to move through the physical world is to let it practice in a dream. Generate the world, generate the data, skip the expensive real-life collection entirely.
With the honest asterisk we kept coming back to. A dreamed world can lie about its own geometry, and a robot can't tell. Getting the dream honest, not just convincing, that's the unsolved part. Watch that space.
Here's what we actually want to know from you, though. If intelligence is getting close to free, what's the first thing you'd build that you couldn't justify before? Not the model, the thing on top of it. Drop it in the comments, we read them, and the good ones shape where we take this.
And if today was worth your commute, follow or subscribe so it's there tomorrow, leave a like, it genuinely helps other people find the show, and send this episode to the one person you know who's still paying frontier prices for everything.
And for the full daily rundown, every story we covered plus the ones we had to skip. That's all on Ground Truth. GroundTruth.day. One feed every day, checked against the source.
The frontier just got cheaper again. We'll see you tomorrow, when it probably gets cheaper still.
Tomorrow's the Grok public release, actually. So yeah, see you then.